Welcome back to the second part of Chapter 6. Let's start off by talking about the multiplication of rational expressions. So, you recall just from, again, the first week of 221, the multiplication of two rational numbers, for example, 5 over 3 times 6 over 7. What we want to do in cases like this is we just multiplied straight across the top and straight across the bottom. Okay, so we would get 5 times 6 divided by 3 times 7, which is equal to 30 over 21, which we could further simplify here. This equals 3 times 10, or rather, here, let's go ahead and further simplify that. This equals 3 times 2 times 5 over 3 times 7, sloppy handwriting, and our 3's will cancel there, and we're left with 10 over 7. Okay, we can do that exact same thing for rational expressions. So let's go ahead and multiply these two values together. So again, just the same way we did with the rational numbers, we're going to multiply straight across the top to get 9x times 10y, divided by 5y times 3xy, which gives us 90xy divided by 15xy squared. So again, we never want to leave expressions like this. We want to simplify them as much as possible. We've got extra terms in there that we don't really need. And if we're chugging out lots of numbers, we're always going to be plugging in numbers that we really don't want to. It's just bad form for the most part. And especially as equations get longer and longer, you want to get rid of as much as possible. So we do that by simplifying, which we get by just factoring our top and our bottom. So 90xy we can factor that as 6 times 15xy. The bottom, similarly, can be y times 15xy. The 15xy's cancel on the top and the bottom, and we're just left with 6y. Okay? Good. That's nice and easy. Let's go ahead and do some division of rational expressions. Division is really just multiplication in disguise. Why do I say that? Let's look at an example. 5 over 3x divided by 5 over 6x can just be written as 5 over 3x times 6x over 5. Why is that? Because, if you'll recall, 1 over, for example, 1/2 is just equal to 2 over 1, right? So I can do that same exact thing with my rational expressions. Oops. So this is nice and easy. I rewrote over where I was going. We can just cancel these 5's like this. We can cancel our two x's. We've got an x in the top and an x in the bottom. Those will divide out. And we're just left with 6 over 3, which I've factored here as 2 times 3. We can cancel our two 3's out here. And we're just left with 2. Nice and easy. Okay, so division is really just put it in a form that you can multiply it. It's easier that way. All right, let's look at adding and subtracting rational expressions. This is where things get a little bit more tricky. Why do they get tricky? Let's look at just adding two fractions again. We've got 5 over 2 plus 1 over 3. What we have to do is find a common denominator for both of these. Okay? And now one common trick for finding a common denominator is simply multiplying the two different denominators together. So 2 and 3 in this case. And then multiplying the numerator by the term that's not present. So for example, over here, we had a 2. We want to multiply that by a 3 on the bottom and a 3 on the top. Okay? Same thing over here. We started off with a 3, so we multiplied this by a 2 and a 2. Okay? So and what that does is now we've got a common denominator in the bottom, so we can just simplify this as 18 over 6, which simplifies to 3. All right, let's look at how we go about finding one of these common denominators if we have these two equations in our denominator. So let's say we've got something really ugly, where we've got, where these are our two denominators, a squared plus 5a plus 6, and a squared plus 4a plus 4. It's really not that not that obvious how we would find this common denominator. We could just multiply these two polynomials together and come up with a common denominator, but that's really not the best way to do it. You'd end up with something very ugly, and it wouldn't be your lowest common denominator. It would be a common denominator, but it wouldn't be the lowest one. Okay, so how do we go about finding the lowest common denominator? Well, just the same way that we did before, let's go ahead and factor this. Let's factor a squared plus 5a plus 6, which you should be able to easily show is a plus 2 times a plus 3. Factor our other term. We get a plus 2 squared, which is actually a plus 2 times a plus 2. Okay, so what we want to do here to find our lowest common denominator, we really want to find all of the separate terms that are in here, okay? So the top, or the a squared plus 5a plus 6 is composed of an a plus 2 and an a plus 3. The second term is composed of an a plus 2 and another a plus 2. So in order to make the top term look like the bottom term, we have to multiply it by another a plus 2. Okay? So this is really just, if we look at this and this is the same as this value up here. Okay? Similarly, if we look at this term and this term, this is just equal to these two terms there. Okay? So now in order to see what these two values would look like, we would want to go ahead and multiply this value, these two values, and these two values to get our lowest common denominator. Good. Let's look at this in practice. Okay, here we've got a big ugly equation. I won't bother saying that, but this is what we've got this expression, we want to add and subtract these different terms together. Okay, so very daunting. What we want to do is find the lowest common denominator. So again, we look at all of our denominators and we factor them. So one term at a time, we've got x squared plus 2x, which can be factored as x times x plus 2. The second denominator is 6x plus 12, which can be factored as 6 times x plus 2. And then 6, which is already in its lowest form, as 6. Okay? So what are the independent terms that we have? X, x plus 2, and 6. Okay? So our lowest common denominator is these three terms multiplied. 6 times x plus 2. And now we can rewrite our initial question in terms of these lowest common denominator. The first term here had the x over x plus 2. It was missing the 6, so we multiply the top and the bottom by 6. The second term could be factored as 6x plus 2, but was missing the extra x, so we multiply the top and the bottom by the extra x term. And the final term only had the 6, so we multiply the top and the bottom by x plus 2 over x plus 2. All right, good. So now let's continue this problem. We finally got it in the lowest common denominator form. Let's go ahead and continue this. Now we've got the lowest common denominator, so now we just add up all of these top terms, which gives us 6x plus 6 from our first term. Second term gives us 2x squared plus x. And our third term gives us x squared plus 2x. All over 6x plus 2. Good, which now we can combine like terms, which simplifies like this. And now we want to factor that top part. Just see if we can clean this equation up anymore. We can factor that top equation as x plus 3 over x plus 2. And what we should see here is that x plus 2 cancels on the top and the bottom. And we're left with a nice simple equation, x plus 3 over 6x. So we started off with something very ugly, very scary looking, and we got it down to something nice and simple. Okay, so again, just to recap, multiplication and division, very simple, just like you did with multiplying fractions. Adding and subtracting fractions is rational expressions is more complicated, just the same way that adding and subtracting fractions was more simple. You have to find a common denominator where that's where a lot of the work comes from, and you just gotta kind of keep chugging through until you can get a nice simple equation. So look through the problems in your book, but this should get you started.